friends! Welcome to the channel. In today's video, we will be going over redox reactions and electrolysis. Just FYI, in this video, we will be talking about the concepts of redox reaction and electrolysis. If you would like to know how to answer the exam questions relating to this topic, I will leave a link in the description box below. So, let's go. First off, what is a redox reaction? By definition, redox reactions are when reduction and oxidation occur at the same time. There are three ways to determine whether a substance is undergoing reduction or oxidation: its electron behavior, its oxygen behavior, and what type of agent is your substance. So let's go into depth about the electron behavior first. We need to see if the elements we're looking at are first gaining or losing electrons. If a substance is undergoing oxidation, it means it will lose electrons. If a substance is undergoing reduction, it will gain electrons. We can use the word oil rig to help us remember this phenomenon. Oxidation is lose, reduction is gain. So then the next question is, how can we tell whether something is losing or gaining electrons? We can do so by creating half-ionic equations. To create a half-ionic equation, we need to consider what is the starting substance, what does it look like at the end. Then from there we can consider the particle number as well as their charge. We can use a sodium as an example. We can start with a sodium ion, and we know that it will become a sodium atom because that's the only form it can take when it comes to gaining or losing electrons. Now we have to look at the particle number by looking at the bottom right of our symbols. In this example, both the sodium ion and the sodium atom have nothing written on their bottom right. So then we can safely assume that they both have one sodium atom and one sodium ion on either side. This means that the particle number is balanced. Now, we need to consider the charge. The only way to manipulate charge is by adding electrons on either side of the equation. Each electron has a -1 charge. So if I add one electron on the left, it will make the left side more negative. If I add an electron on the right, it will make the right side more negative. So for our sodium's case, I have to compare my sodium atom and my sodium ion. A sodium ion will always have a +1 charge. To find out more on the different charges of different ions, you can click on the link below where we can go into detail about the ions. Now, on the other hand, a sodium atom will naturally have no charge. This means that on the left side, we have a +1 charge, and on the right side, we have 0 charge. So in order to balance out the two sides, we need to add a -1 on the left side. This means that I need to add 1 electron on the left side. Doing this will make my left side have an overall charge of 0, balancing both sides out. Let's do something similar, but this time with a chloride ion. A chloride ion will have a -1 charge. On the other hand, a chlorine molecule will always be written as Cl2, because the chlorine molecule is a diatomic molecule. So firstly, we're going to compare the particle number. On the left side, there's 1 chloride ion. On the right side, there's 2 chlorine atoms that come together to form 1 chlorine molecule. This means that the particle numbers on the left and on the right are not the same. In order to make them the same, I need to put 2 in front of the chloride ion on the left. This will mean that I have a total of 2 chloride ions on the left and 2 chlorine atoms on the right, and that will make up 1 chlorine molecule. Now that my particle number is balanced, let's try to balance out the charge. On the left, each chloride ion has a charge of a -1. Considering there's 2 chloride ions on the left, that means that there's a total of -2 charge on the left. And on the other hand, on the right side, because the chlorine atoms are found in 1 molecule, again there's no charge. To balance out the charges, we need to put a -2 on the right side this time, so that the overall charge on the right would become a -2. And because we have to put a -2 charge on the right, it means that actually I have to add 2 electrons on the right side as well. Going back as to why we were creating all of these half-ionic equations, we can use these to help us find whether or not a substance is undergoing oxidation or reduction. So let's go back to our sodium example. For sodium, it went from sodium ion to its sodium atom. On the way to becoming the sodium atom, the sodium gained 1 electron because we put electrons on the left side. This indicates that the sodium has actually gained an electron. And as we mentioned earlier, when the substance has gained an electron, it will have undergone reduction. So the sodium ion has actually undergone reduction. Now, then let's look at our chloride example. Our chloride ion became a chlorine molecule by losing 2 electrons. We show the loss by drawing the 2 electrons on the right side. Going back to our oil rig, this means that the chloride ion has undergone oxidation because it has lost electrons. Another way to determine whether something has undergone oxidation or reduction is by looking at the oxygen behavior. We'll use this reaction to explain what we mean. If we compare what the iron looks like on the reactant side and the product side, we can see that the reactant is bonded to oxygen, whereas the product side, the iron is by itself. This means that the iron has literally lost oxygen. And if we refer back to our table, losing an oxygen means that it has undergone reduction. On the other hand, if we look at the carbon monoxide, it was originally attached to 1 oxygen atom, but then on the product side, it can be seen as carbon dioxide. This means that literally the carbon monoxide has gained an extra electron, so we can say that carbon monoxide has undergone oxidation. The last way to determine whether something has undergone oxidation or reduction is by looking as to whether or not they are classified as oxidizing agents or reducing agents. If a substance is classified as an oxidizing agent, itself is undergoing reduction, whereas if a substance is undergoing oxidation, it will be called a reducing agent. So this is where we will then diverge. If you are a double award, you don't need to watch this part of the video unless you want to, which I hope you do, and I do appreciate that. If you're a triple award, you will still need to keep watching. To set up this experiment, we need a beaker with 2 electrodes. One electrode will be called a cathode, the other electrode will be called the anode. These 2 electrodes will be connected to external wires, which will be connected to a battery, with the anode being connected to the positive side and the cathode being connected to the negative side. If there were more than 1 cation present in the solution, then the cathode will react the less reactive cation. We can refer to our reactivity series for that tidbit. On the other hand, if there were more than 1 anion to choose from, the anode will react the more reactive anion. As a rule of thumb, halides are the most reactive ions, followed by your hydroxides, and followed by any other anions after that. Using aqueous sodium chloride as an example, we can break down the sodium chloride ions into sodium ions and chloride ions. On top of that, because this is an aqueous solution, it means that water is present, which means that water can break down into hydrogen and hydroxide ions. Very important, do not say hydrogen and oxide ions. Water must break down into hydrogen and hydroxide ions. Now going back to our experiment, this means that the anode can pick up either the hydroxide ions or the chloride ions, while the cathode can pick between the sodium ions and the hydrogen ions. Referring to our rule of thumb, chloride ion is a halide ion, and because the anode will attract the more reactive anion, it will be the chloride ion that will be attracted to the anode more. In the cathode, hydrogen is the less reactive cation compared to sodium, which means that the hydrogen ion will react in the cathode. Now that we've chosen the ions that will react, we need to recall what their elemental forms are. Both chlorine and hydrogen are diatomic molecules, meaning the chloride ion will turn into a chlorine molecule, Cl2, and the hydrogen ion will turn into the hydrogen gas molecule, H2. From there, we need to complete these half-ionic equations. Because both molecules are diatomic, we need to add a 2 in front of their ionic forms. Then, for the final step, we need to add electrons to balance out the charges. 2 chloride ions have a negative 2 charge total, 2 hydrogen ions have a positive 2 charge in total, and both their molecules have 0 charges. So to balance everything out, we need to add 2 electrons on the right side with the chlorine molecule, and 2 electrons on the left side with the hydrogen ions. So this means that the anode has undergone oxidation because the chloride ions have lost electrons, and the cathode has undergone reduction because the hydrogen ions have gained electrons. Quick tip, this has always been the case anyway, so another way to remember which reaction occurs at which electrode is to remember anox and red cat. This may all seem boring and tedious, but this is how industries extract metals and electroplate some jewelry to make them look pretty. So, if you want to learn more about these processes, leave a comment down below. In summary, redox reactions occur when oxidation and reduction occur at the same time. To determine whether a substance has undergone oxidation or reduction, we need to see whether or not it has gained or lost electrons, gained or lost oxygen, or are classified as reducing agents or oxidizing agents. Last, electrolysis is an experiment that makes use of these redox reactions. Quick word before we go, can I ask you guys a favor? If you found this video useful, can I ask you to subscribe to the channel and or like this video? It would help the channel grow, and in return I will make sure the bigger the channel gets, the better the content gets. Thank you for watching, and I hope to see you in the next video.